Okay. Starting with a quiz where we factor these three things. That x squared plus 5x minus 24 equals x plus a times x plus b. So what are our possible values of a and b? Because we see if we multiply this out, we are going to have a times b, and that has to give us negative 24. Any other product we have in the distributive law here is going to involve at least an x. So the only thing that doesn't have an x is a negative 24. The only thing that doesn't have an x here is AB. So A times B has to equal negative 24. So we could have A is 1, B is negative 24. If A is 2, well, 2 goes into negative 24, negative 12 times. If A is 3, we divide 3 into negative 24, we get negative 8. So we know 3 times negative 8 is going to give us negative 24 and so forth. And 4, negative 6 will give us negative 24. Now, the next number we might try for A would be 5, but it won't go into 24. We could try 6, but it's then going to give us negative 4. Well, let's go ahead and do that. Except I'm going to do it a different way. I'm just going to write these numbers down, A numbers, but with negatives. And then it's going to be clear that we get 24, 12, 8, and 6. Okay, that's 8 possible pairs of numbers A and B. Now, it's not for sure that any of them is going to give us 5x. But if any of them do, there's probably going to only going to be one. We could prove that there could only be one. Okay, so let's try.
You know what?
X plus 1 times x minus 24. That gives us x times x minus 24 plus 1 times x minus 24, which gives us x squared minus 24x plus x minus 24, and that's x squared minus 23x. And I wrote 2x instead of 24, but then it's minus 24. Well, we have the x squared and we have the minus 24, but we sure don't have 5x. We've got negative 23x. How did that happen? Well, this number was so much bigger than this number that when we multiplied x times the negative 24, we got the negative 24x, then multiplied 1 by x and got x. We got something that was close to negative 24. It wasn't even close to 5. So maybe we should look through here and see if any of these pairs add up to negative 5, because 1 and negative 24 is negative 23. If we did this with x plus 2 and x minus 12, we'd have a 2x, we'd have a negative 12x. I replace this number by negative 12 and this number by 2, I would get negative 12x here and 2x here. That would give me negative 10x. That's not going to work. Okay. Now, if I did 3 and negative 8, well, let's try that. That gives us x times x minus 8 plus 3 times x minus 8. And that gives us x squared minus 8x plus 3x minus 24. That gives us x squared minus 5x minus 24. How does that match up? Well, we need a plus 5x here. We've got a minus 5x here. So this isn't quite right, but it tells us that a 3 and an 8 with opposite signs will give us something of magnitude 5. So let's just reverse the signs. Now let's try x minus 3 times x plus 8. It's going to give us x times x plus 8 minus 3 times x plus 8 gives x squared plus 8x minus 3x minus 24. 8x and minus 3x is 5x. So this one checks. So here's our solution. And we could draw the conclusion then that x squared plus 5x minus 24 equals x minus 3 times x plus 8. Now, this is the process I advocate everybody learn, but there is an algorithm that people are going to tend to forget. If you practice this and do the trial and error, two things are going to happen. You're going to get better at using the distributive law, and you're going to have something you can remember how to do in case you forget the algorithm. Now, the algorithm is well, x plus a multiplied by x plus b equals x squared. I don't have room to write that out. So I'm going to go ahead and use this part of the board. We'll just smudge this out. And let's make sure I can see this much of the board. Now, what's the camera doing way over there? I think the camera's zoomed in some more, but that's as far as it zooms. I don't know what's going on. Okay, so let's see, we can come over to here. So I can move this over and move this over. Okay, now what we can do is we could write x squared plus 5x minus 24 equals x plus a times x plus b. So that x squared plus 5x minus 24 equals x squared plus ax plus bx plus ab. And I'm skipping a step of the distributive law. You should be able to write this out with every step included. And what we end up with is x squared, there it is, ab, there it is. We can factor x out of the ax plus bx to get a plus b times x. So now a plus b has to equal 5 and ab has to equal 24. So we try to negative 24. So we try to find two numbers that multiply out to negative 24 and add up to 5. Well, again, we could list all our possible factors and see until we find one that adds up to 5. Okay, 1 and negative 24. Well, a equals 1, a equals b equals negative 24 satisfies this. AB equals negative 24, but a plus b is negative 23. That's not going to be any good. 2 and negative 12 isn't going to work because 2 times negative 12 equals negative 24. But add 2 to negative 12, we get negative 10. Well, we keep on going down the list until we get to negative 3, 8. Okay, negative 3 times 8 gives us the negative 24. Negative 3 plus 8 gives us 5. Okay, so we try. Different pairs A and B whose product is 5, negative 24. And whose sum is 5. Okay, looking at our list of possible products. A equals negative 3, D equals 8, gives us AB equals negative 24, A plus B equals 5. So A and B are the numbers that work here. And our factor is this. Now, your book basically tells you this. It doesn't tell you why. And not everybody is likely to remember why, although you really should remember why. It's best if you remember why this works, but if not, you can always do this and try the different combinations, use a little common sense, try the ones that are most likely to work. So you should always be able to do this. And then use the distributive law correctly, which some people had trouble doing. Okay. Now, moving on to the other problems, the 4x squared, y to the fourth minus 9z squared, and so forth. Move this board over here. And yeah, we're okay here. Okay. Okay, is this of the form? Is it a form A plus B times A minus B? Which equals A squared minus B squared by the distributive law. Review that if you don't remember. Why this is true, because if you don't remember why it's true, you get stuck on a test, you get stuck with the whole idea. Because you just, pressure the test, or it's been a while since you looked at it. You're not aware of how to multiply this by this to get this, okay? Well, let's see. If so, A squared would be 4x squared y to the fourth, which implies that A equals 2xy squared. If A squared equals this, then A equals the square root of this, which is 2, the square root of x squared, which is x, the square root of y to the fourth, which is y squared. So far we're okay. That's an A squared. That's a perfect square of some other expression. And b squared equals 9z to the fourth, which implies that b equals, well, the square root of 9 is 3, square z to the fourth is z squared. Now you can always check. If you square this, you write this with a square on it, it's going to give you this. If you write this with a square on it, it should give you this. In that case, this value of a and this value of b, this expression equals a squared minus b squared. So that 4x squared y to the fourth minus 9z to the fourth equals 2xy squared. Sorry, 2xy I don't have room. I'll write the equals down here, equals 2xy plus 3z squared multiplied by 2xy minus 3z squared. So again, if this is a squared, then a has to equal this. And if b squared equals 9z to the fourth, then b equals the square, then b equals 3z squared, square root of 9z to the fourth. Since that's so, then this expression is a squared minus b squared. The square of this, which is this, minus the square of this, which is this. Therefore, it can be written as a plus b times a minus b. So a plus b is 2xy squared plus 3z squared here. And I left my square off the 2x, off the y here. Okay. So again, a is 2x squared, 2xy squared, b is 3z squared. So here's our a plus b, is this. And 2xy squared minus 3z squared, which is our a minus b. And we write that here. So the result is quantity 2xy squared plus 3z squared times the quantity 2xy squared minus 3z squared. Again, something you got to do a lot of practice on before it becomes natural to you, but you should always keep in mind why it's true. Okay, the third problem was x cubed minus x squared plus 12s. Well, first of all, you can factor out an x here. We get x times x squared minus x plus 12. And without going through the details, leave everybody to go through the details, this would be, is that plus 12? Did I write plus 12? Yeah, I should have written minus 12. Because it was a plus 12, that just wasn't going to work. Okay. So I apologize if you attempted to work this one. You probably realized it doesn't work, but with your trial and error, it'll be easy to adapt what you've done. to the intended statement. Okay, so that's what you do with this. First, you see that you have an x that you can factor out. Then you factor the trinomial that you get just using the methods we've already seen. Okay, well, now we're going to use the idea of factoring to solve some equations. Before we do that, write down an equation here. Can we solve it? In other words, can we find one or more values of x that make this so? But we're going to discuss this for a minute before we write anything down. And so you're looking for a number that makes this zero. Well, what would make this zero? What would make x minus 3 zero? Well, because if x minus 3 is zero, then it doesn't matter what x plus 5 is. When we multiply zero by whatever x plus 5 is, we're going to get zero. Because you multiply any number by zero, you get zero. So x minus 3 could equal zero, and that would make the whole thing zero. Or x plus 5 could equal zero, which would make the whole thing zero. If x minus 3 equals zero, then, well, a lot of people like to write it out like this. You get x minus 3 plus 3 equals 0 plus 3, so that x equals 3. Minus 3 plus 3 just gives you 0, so on this side you're left with x. 0 plus 3 is 3, so x is 3. And down here we can do the same thing. We could add -5 to both sides. And we get x plus 5 minus 5 equals 0 minus 5. And 5 minus 5 is 0. That leaves us x. 0 minus 5 is -5. So we say our solution set consists of -5 here and 3 here. Let me give you another problem. And kind of want this to be visible. So let me put this over. Well, I've got it in part of the board that I can't make visible. Maybe I can. Okay. So let's try. Let's try this, see if you can figure out at least one number that makes that zero. Okay, so everybody's written this out pretty well. You write x plus 5 equals 0, just imitating what I did, and then you write out x plus 7 equals 0. And then you write out x minus 4 equals 0. This is what I've seen on most papers. I don't see the word or. If you're going to imitate what I did, you're going to write that word or. And I recommend that you imitate it literally for the first few problems until you come up with your own way of seeing it. We don't want to eliminate any of the logic. Okay? Well, then we solve. And it's pretty obvious. X plus 5 is 0. I've got 3 little dots here. We would go ahead and do the solution, adding -5 to both sides. And we get 3 possible solutions. And then we write down solution set. -7, -5, 4. You can write these numbers in any order, but logical order from least to greatest is probably the easiest to recognize. Okay? But any order is actually valid. Okay, now let's try one more. All right, 2x plus 6 times 4x minus 8 equals 0. Let's try to follow the exact form that I used until you get to the point where you got to do just a little more algebra. Okay, so we have this equation, and everybody's done quite well with this. 2x plus 6 equals 0, or 4x minus 8 equals 0. And this equation is solved. You can add -6 equals -6 to this equation, and you get 2x plus 6 minus 6 equals 0 minus 6. Now 6 minus 6 is 0, so we have 2x plus 0 equals what? Well, 0 minus 6 is just -6. If you add 0 to -6, you're not adding anything, you still have -6. Then you have 2x equals -6, so that (2x minus 2 equals -6 over 2). So that x equals -3. Now that's written pretty low on the board, and I never can trust the camera. I'm going to raise that up just a little, kind of balanced there. So, and it almost looks like we got an x squared or -3 squared. Okay, now I'm not going to write out all the details here, but we start by adding 8 to both sides by adding the equation +8 equals +8 to the equation 4x minus 8 equals 0, because we don't want that 8 there. That gives us 4x plus 0 equals 8, which is 4x equals 8. So that 4x over 4 equals 8 over 4, and x equals 2. So our solution set consists of two numbers, -3, 2. If you put -3 in, you get 2 times -3, which is -6, and add 6, you get 0. You get 0 here, and then, of course, over here you get -20, but 0 times whatever this is, whether it's -20 or something else, 0 times this quantity is going to be 0. And if x equals 2, 4 times 2 minus 8 is 8 minus 8, and that is 0. So again, whatever this number is multiplied by 0, and we get 0. Now let's solve this equation. X squared plus 5x plus 6 equals 0. My hint is we first have to factor x squared plus 5x plus 6. So take a minute, see if you can factor that, and rewrite the equation in factored form. Okay, so we factor and we get x plus 2 times x plus 3 equals 0. And now we're on familiar ground. Now we know that we just write down x plus 2 equals 0 or x plus 3 equals 0. We solve this and we get x equals -2 or x equals -3. Our solution set is no. I said we usually go from least to greatest. I did it the opposite way. So I'm not totally consistent, but that's a valid solution. So let's try this. Okay, we start by factoring greatest possible monomial. And now we have a trinomial that we can easily factor. And this breaks into 3 factors, each possibly equal to 0. We have x, so x could be 0. And if x is 0, that makes the whole product 0. If x minus 3 is 0, the whole product is 0. Or x plus 2 could equal 0. So this is still x equals 0. This is x equals 3. Or x equals negative 2. Let's make sure I'm on the screen yet. Solution set then is the set that I'll write as negative 2, 0, 3. And again, just to make sure that's all visible, I've propped up one end of the board